Matter can transition from solids to liquids to gases. We call these phase changes. When we change from a liquid to a gas, a certain amount of energy is required to change any liquid to a gas. This is called the latent heat of vaporization. Energy needs to be added to the liquid in order to allow the molecules to have enough energy to escape the bonds that hold them to other molecules in the liquid. So when you apply heat to a liquid, the liquid can start to evaporate. However, a boiling liquid will not change temperature. The liquid will stay the same temperature until it has all boiled off. Liquids can also spontaneously evaporate, however, without any added heat. This is because not all the molecules in the liquid are vibrating at the same velocity. Molecules within a liquid are constantly vibrating. As molecules get closer together, they repel, and as they get farther apart, they attract to each other. However, some molecules can be vibrating so fast that as they get farther apart, despite the fact that they're attracted to each other, it can be moving so fast that it completely breaks this bond, and it can escape out of the liquid. The molecules are all traveling at different velocities, and since some of the molecules are traveling at a high enough velocity to escape, they can then evaporate. Once they evaporate, however, a new velocity profile forms. The new velocity profile has a lower average velocity, which means it has a lower average temperature. This is how evaporating liquids can stay cold. Sweating, for example, is a way to keep the body cold, because as the sweat evaporates from someone's skin, the sweat gets colder, pulling heat away from the body. This is also how coolants such as alcohol work. They evaporate quickly, and a lot of heat gets pulled out of the alcohol, which means heat can be pulled from whatever object the alcohol is in contact with. The relative humidity can affect how fast this evaporation takes place. Because of the humidity, the molecules in the liquid are not necessarily actually evaporating more slowly. What's happening is molecules of water from the air are condensing onto the liquid, and the liquid is evaporating. But it's evaporating faster than molecules from the air are condensing into it. If a surface is very cold, dew can accumulate on it because the relative humidity above the surface is actually more than 100%, which means the air is saturated and liquid can condense onto the surface. With liquids other than water, the relative humidity for these liquids is basically 0%. Using alcohol as an example, the relative humidity of alcohol in the air is nearly 0%. There's basically no alcohol floating around in the air. However, if we're talking about the evaporation of water, there can be a large amount or small amount of water vapor already in the air. This is why when it's humid, it tends to feel hotter than if it's dry at the same temperature. This is because the sweat is less effective at cooling you because it can't evaporate as fast and therefore can't pull as much heat out of the body.